Hi folks, this is page 420, number 25, and here they're giving us a 3D vector, and they want us to find the angle between this vector and the y-axis. Okay, and this is where we're going to use those direction cosines. So remember that we had alpha, beta, and gamma represent the angles to the x-axis, y-axis, and z-axis. Okay, and we determined that we could use cosine to determine these angles. So if I want to determine the angle to the y-axis, that's the one we call beta. And the way we determine that is with the ratio given by the y component over the magnitude of the vector. Okay, so essentially when we looked at the 3D model, we saw that we could form a right angle triangle where the y component represented the adjacent side of that triangle, and the magnitude of the vector represented the hypotenuse, okay, which is why we use cosine. Okay, so in the end, what we're solving here, really simple, is just cos inverse of the y component, which is -3, over the magnitude of the vector, which is just going to be 12 squared plus -3 squared plus 4 squared. Okay, and that's it. That gives us our answer. Okay, so there's no need at all to try to draw this diagram out. Okay, so let's calculate that. We've got inverse cos of -3 divided by this big square root. So what do we have? We have 144 plus 9 plus 16, and we end up with 103.34 degrees. Okay, and that's it. So again, you need to know the relationships between these direction angles and the components of the vector. So in this case here, because it was to the y-axis, it was the y component over the magnitude. If it was the alpha to the x-axis, it would be x over magnitude. Gamma would be z over magnitude. Okay, that's it for this one.